Okay, so next speaker is from Red Hat, William Benton, and he's going to talk about how you can install and seamlessly get Spark running on Fedora. And for your information, the other track now, track A, seems to be on time, so we're completely synchronized with them.
We're in preview, right?
They're probably done with the whole day in an hour or two.
Okay, hi, I'm Will Benton, and I'm a software engineer at Red Hat working on distributed computing projects. But today I'm here as a member of the Fedora community, and I'm a member of the Fedora Big Data Special Interest Group. And I'm going to talk to you about some work that we've been doing in those communities to bring Spark and related projects to Fedora. First, though, I want to talk about why we need quality downstream packages for operating system distributions to begin with. The Spark team has done a really great job of making Spark easy to install from source, but there are still major advantages to having well-integrated packages for developers and for end users. And as we see with Big Top, packaging is really important and a valuable thing. Now, some of these benefits we get as a consequence just of having software in an appropriate container, like an RPM or a deb package. But others are really only available when you have packages that satisfy operating system distribution guidelines, like the Fedora packaging guidelines. So I'm going to talk first about how these how users benefit from these kinds of packages. The first thing users want to see is ease of package installation, upgrade, and removal. Installing a single package is often pretty easy, but the difference between upgrading a bunch of related packages by hand that you've installed locally and simply running yum update or a similar distribution-specific automatic updater is enormous. And obviously, we don't want people to stop using our tools, but if users know that they'll be able to uninstall something as easily as they installed it, that really lowers the barrier to entry to trying something new. Another benefit to users is automated dependency management. If I want to install a cool project, I don't want to have to care about all of the things it transitively depends on. I want a dependency manager to handle that for me. If a security bug gets fixed in a library that I'm using, or that one of my dependencies is using, I want to be able to install that fix and not have to worry about it at any point. And then finally, users benefit from system integration with their system in an idiomatic way. This can be something as simple as following the file system hierarchy guidelines. If I install a package, I want it to put files where I expect them to be in the file system and where other programs on my system expect them to be. It can be something a little more involved, like integration with systemd or init or upstart or whatever I'm using to launch daemons on my system. And it can even go as far as something like integration with SE Linux, which for those of you who've seen a lot of integration with SE Linux, a lot of times the first instruction is turn off SE Linux, right? So we want all of those things, and we can get them from packages. The developers often make their own packages, but packaging and developing are really different skill sets. As someone who's primarily a software engineer but has done a fair amount of packaging, I've been humbled to learn this lesson firsthand, right? These aren't skills that software engineers are born with. They're things you have to pick up. So if upstream developers can delegate some of the integration, testing, and polish work that are involved in really getting these packages to work well, that frees them up to work on enhancements and bug fixes. Furthermore, we have an automatic distribution channel that cares about making projects easy for users to consume, which is a great benefit for upstream developers. Finally, everyone benefits by spreading around the work of pushing the leading edge. Downstream distributions can identify problems that new users run into, problems with new versions of libraries, etc., and work with upstream developers to get these fixes integrated back upstream for the rest of the community. Testing and quality assurance procedures developed by one distribution improve the software quality for everyone. These things are transferable. And fixes to work with, say, new compiler versions, new runtimes, new library versions that might show up in the latest Fedora will also work with those tools and packages when they show up in other distributions. Finally, downstream packagers also typically do a great job of tracking known security vulnerabilities and determining the scope of their impact. And downstream packagers are also a great resource for helping to ensure that your code is compliant with open source licenses, which is another thing that I don't want to have to worry about as a developer. However, there are a few unique challenges that we have to overcome in order to realize these benefits and have idiomatic packages of complicated software projects. And we'll see that these are caused by differing philosophies between the way that we manage complexity while building new software and the way that downstream distributions manage complexity while packaging software. And as Konstantin said, there's really this gulf between sort of the agile model and the enterprise model. We'll see this here. So I want to start, though, by talking about some trends in the way people develop software these days. This is things I've noticed in my own projects. I suspect you have as well. But the first thing we see is extremely fast-moving language-specific software ecosystems. You'll have a sort of Wild West feel, when these things are starting off. That there's a lot of people inventing solutions to new problems, and a lot of these language-specific ecosystems are driven by cool new applications. For example, maybe not everyone is excited about learning Scala, but I bet a lot of you in this room who have learned Scala did so because the Scala interface is a really wonderful way to interact with Spark. In the past decade, we've also seen similar application-driven language ecosystems around Ruby with Ruby on Rails, JavaScript with Node.js, and a lot of distributed systems projects in Erlang. Another thing you see with these language-specific ecosystems is that they often have opinionated, sort of do-it-most build-in dependency management tools. And once we have that kind of tool and we're using it to manage our projects, we get this culture of making software out of components that fit together without worrying about how it impacts the rest of the world. My app might demand different versions of libraries and tools than your app does, but that's okay, because this dependency management tool will let us each bundle our own. I can assume that I'll be able to build my app against particular versions of libraries that work and deploy it against those same versions, that I'll be able to freeze and sort of pin those dependencies forever, and that they'll always be available for me to download again from a third-party repository if I need to get them at some point in the future. And this really leads to a sort of DevOps model where applications are developed in one environment and we have a lot of effort going into automation tools to reproduce that environment in production. And this is one way to make it easier to assemble and deploy systems with a lot of moving parts. It's a way that's really at odds, though, with the sort of enterprise model that we see in downstream distributions, which solve some of the same problems, but in radically different ways. And I'm going to talk now about how Fedora solves these problems. The first thing we do in Fedora that's notable, and I'm not going to talk about everything, and of course there are exceptions to all of these rules, or to some of these rules, but in Fedora we build everything from source, from pristine upstream tarballs with some distribution-specific patches. We try and keep those as minimal as possible. Because we do this, Fedora can be self-hosted. That is, it's possible to build Fedora on top of Fedora with no extra bits. As a concrete example of what this isn't, if I'm building a Java application these days for Fedora, I wouldn't pull down binaries from third-party repositories like I would with a typical Maven or Ivy build. Instead, I would only build against versions of those dependencies that are already packaged for Fedora. In fact, the process that builds packages for Fedora runs in a restricted environment with access to Fedora packages, but no general network access. And doing this has a few advantages, but a couple of the most important ones are that it makes it easier to ensure that everything we're doing is built on the releases we think it's built on free software, and that users will always be able to rebuild packages with their local changes to the source, even if they're using a release that's no longer supported. This also eases support when there's a new version of Fedora and lots of packages change versions at once, because you can rebuild everything, figure out what doesn't work, and then what has to be changed. Another big difference is that while a lot of opinionated software dependency management tools are designed to make it easier to manage this problem, this sort of DLL hell problem, right, of having a lot of versions of libraries on your system at once, so each can be used by different applications, downstream distributions take a different approach. They solve this problem by typically restricting to one version per library and not allowing bundling of libraries or code in other packages. The really nice consequence of this sort of policy is that if there's a security problem or performance bug or just a correctness bug in one of these libraries, it only needs to be fixed once, and every package that depends on that can benefit from that fix, rather than fixing once for each version of a library, or even worse, once for each bundled copy of a library. Now there's a trade-off here, right? This is more work for packagers in the first place, because they might have to patch an upstream project and contribute that patch back so that it works with the latest version of a dependent library. But that gets paid back in the future when there are fixes to those dependencies. In the case of Spark, we had some additional challenges to deal with. Older releases of Fedora had a package for Scala 2.9, but no one had really packaged any projects in the Scala ecosystem before we started working on Spark. Now, there are other language-specific ecosystems that had already been pretty well integrated into the Fedora packaging system. Maven on the JVM, Ruby gems for Ruby, and Python eggs. Those are all integrated into Fedora packaging, but we were basically starting from scratch with SBT, the simple build tool, and Ivy, which SBT uses to manage dependencies. SBT builds itself, which adds another layer of complexity if you're going to be adopting these principles we talked about with packaging. And it really wants to take control of build and dependency management aggressively, to the point of downloading private copies of compilers and runtimes. Again, this is great if your goal is to have a reproducible development environment that you can move to production. But Fedora packages need to give Fedora room to do this. We developed some Ivy support for Fedora in sort of an ad hoc way, and the community is working on more general support. Making matters worse, Fedora 19 broke Scala support, so when Fedora 19 came out, it came out without a Scala package. So now I'm going to sort of quickly run through our progress, both on some big data projects that work well with Spark and on Spark itself. First up is Hadoop 2. Many people are interested in using Spark with HDFS, of course, or Yarn. Hadoop 2 is available in Fedora 20. It was a heroic effort by some members of the Big Data SIG. I'd especially like to call out Rob Ratai to get this working, and this was the first Hadoop packaging for an operating system distribution. Tachyon also obviously works well with Spark and HDFS. My colleague Tim St. Clair packaged this, and it's been reviewed and accepted into Fedora 20 as well. As I mentioned earlier, we had some problems with the Scala package in Fedora 19, but I've gotten that building again, and we have a stable foundation for getting Scala projects into Fedora, starting with Fedora 19 again. And Mesos is under review currently for inclusion in Fedora. SBT, not only an important component of building Spark itself, but it's probably the first step in building an application that depends on Spark, we have a bootstrap build for this. There were a lot of challenges to overcome there, and that will be under review soon. So now that we've looked at some of these projects that work really well with Spark, we'll just talk briefly about where we are with Spark proper in Fedora. So we have a build of Spark on Fedora using our environment. Specifically, I'm able to take a few Fedora-specific packages and build the Scala 2.10 branch of Spark with my locally built SBT for Fedora. So the only hurdle really left to getting Spark under review for Fedora at this point is getting SBT under review, because Spark and some of its dependencies depend on Fedora. So I'm going to close by suggesting just a couple ways that you can get involved and help this effort. First, if you use Fedora, try out our packages. If you love them, let us know. If you have problems, definitely let us know. When you're developing software, please consider what it will be like to package. Don't abandon all the cool tools you have, but try and go with something simpler if possible. Right? And then if you developed a cool open source application that depends on Spark, let us know. We'd probably like to package it or incorporate it into Test Suite as possible. Thanks.
Okay, any questions? Okay, so maybe I can ask a question while the next speaker is getting set up. Paco? Yeah, great. Yeah, so how hard is it to, like, for people that are external to the Fedora project to contribute with one of these software packages that come out of the box with Fedora?
I'm glad you asked. Certainly there's no barrier to entry to testing Fedora packages. Anyone can sign up for an account on the Fedora system and package and test a package. There is a well-defined process for getting sponsored as a packager, and there are clear guidelines for how to do that. So please see me offline if you're interested. Thank you.
Thanks.